Imagine rewinding the universe like a movie. Galaxies would drift closer and closer until everything was squeezed into one unimaginably hot and dense state. This is what scientists call the Big Bang, the beginning of space and time itself, about 13.8 billion years ago. But how do we know this happened? Let's explore the powerful evidence that makes the Big Bang one of the most reliable scientific discoveries ever. The first clue came in the 1920s. Astronomer Edwin Hubble found that the light from distant galaxies was stretched to redder wavelengths. The farther away, the faster they were moving. This means space itself is expanding. And if it's expanding today, running the clock backwards shows it must once have been packed into a much smaller, hotter state. But the strongest proof comes from the faint glow left over from the early universe, the cosmic microwave background, or CMB. This light has traveled across the cosmos for over 13 billion years, ever since the universe cooled enough for atoms to form and light to move freely. Satellites like COBE, WMAP, and Planck have mapped this glow across the entire sky. Its tiny temperature ripples are like a baby picture of the universe, and they match exactly what the Big Bang theory predicts. Those ripples are more than just pretty patterns. They let scientists measure the universe's age with incredible precision, about 13.8 billion years. And here's the remarkable part. This number doesn't come from one source alone. It matches other independent ways of measuring, like the brightness of ancient stars and the rate of expansion we see today. Another test comes from chemistry written into the cosmos. In the first few minutes after the Big Bang, the universe was hot enough for nuclear reactions. They forged mostly hydrogen, about 25% helium, and tiny amounts of deuterium and lithium. Billions of years later, astronomers measured these elements in ancient gas clouds and stars, and they matched the predictions perfectly. That's like checking the recipe of the universe's very first moments. Even the way galaxies are spread across the cosmos confirms the Big Bang. Early sound waves in the hot plasma left faint ripples, called baryon acoustic oscillations. Today, vast galaxy surveys reveal the same patterns across hundreds of millions of light-years. It's another independent fingerprint of a hot, dense beginning. What makes the Big Bang so convincing is that all these clues agree. Expansion, the cosmic microwave background, the amounts of hydrogen and helium, and the large-scale patterns of galaxies. Four completely different lines of evidence pointing to the same story, the same timeline, the same age of the universe. Of course, science never stops asking questions. New telescopes like the James Webb Space Telescope keep looking deeper into cosmic history, and debates continue about details like the exact expansion rate. But instead of weakening the Big Bang, these tests make the evidence stronger, because no alternative explains all the observations as well. So, how do we know the universe is 13.8 billion years old? Because four different cosmic fingerprints all point to the same answer. The Big Bang is more than a theory. It's one of the most tested, reliable scientific explanations we have for our cosmic origins. If you enjoyed this journey through time, hit like, subscribe, and let's keep exploring the universe together.